All right, everybody. So today we're going to go over energy levels. Oh my gosh, I can't get my screen to properly fit. All right, we're going to go over energy levels, but first we're going to kind of do this bell ringer that we did today for class. Okay. So if you want to, go ahead and pause this right now, and you may want to write this down in your notebook. Okay, I think this is good notes. It'll just take a second. So how many protons does bromine have? Br, that's the atomic symbol, right? And you guys should have known that from the last lab that you did. That was on that Google Forms. Should have kind of looked like this. It would talk you through the periodic table and how many protons, neutrons, and electrons a given element had. And I also told you what the atomic number was, told the atomic symbol, and the atomic mass. Okay, so Br, it has 35 protons, right? And how do you find that? You simply go to your periodic table, and if you don't have a periodic table, you can Google one. I'll go ahead and send out a periodic table that I like to use, but you can Google them, and they're pretty easy to find on the internet. They're very universal. But anyways, I just go through, I look for Br in my periodic table, and I see that Br has 35. So the atomic number represents the number of protons, so that's 35. All right, but then it also says, what's the mass of bromine? So again, I'll go to my periodic table, and I'll start looking until I find bromine again. And at the bottom, it says 79.90, right? And so if I look on my lab that I did, it says atomic number is at the bottom, and it's usually, most of the time, it's a decimal point. And what I say that was 79.9. Yes. So the atomic mass is 79.90 AMU. And it doesn't say AMU on there. But what is AMU? Sorry, you can't see it because of my head. But AMU actually stands for atomic mass unit. Okay? AMU, atomic mass unit. That's all you need to know. You may see it every once in a while on a worksheet or somewhere else. And if you see blah, 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 AMU, that's talking about atomic mass units. That's the only reason why I'm throwing that in there. All right. And then I asked the kids today, I said, how come tellurium, Te, weighs more than iodine? How many neutrons do they have? You should write this question down in your notebook. So if you go ahead and look at your periodic table, you'll see tellurium actually comes before iodine. And we would think that tellurium would weigh less than iodine because if we look at the number of protons they have, tellurium actually has 52 protons, where iodine has 53. So you just kind of automatically assume that as you go on and the elements get bigger, they would obviously weigh more than the next because of this right here. All right, so if you remember from the last lab again, the atomic mass, right, can be found down here, and it says the average mass of the atoms in an element, okay? So an element is kind of like a category, or it's a species. I kind of explain it as like a species of deer, like the white-tailed deer population around here. We talk about them as a whole, and if you wanted to talk about what's the average weight of white-tailed deer, right, you kind of gather as many white-tailed deer you can, you weigh them up, and then you find the average. That's the same thing with this, is I can look at a single atom, an individual atom, and it has a specific mass, like a white-tailed deer. If you go shoot one this winter for deer season, it will have a specific weight to it. But if I compare it to the average around here, that's the difference, right? So when I'm looking at the weight of a single atom, it can be different from atom to atom. But when we're talking about the element, it takes the element as a whole in the universe of, let's say, tellurium and iodine, okay? So anyways, how do we find the atomic mass? Well, the atomic mass will always, always, always be on your periodic table, okay? So in order to find that atomic mass, Am equals protons plus neutrons, okay? And so we haven't looked yet at our second part to this question where it says, how many neutrons do they have? And so this is where we got to try to answer this question. Why does tellurium actually weigh more than iodine? Well, it actually has to do with the number of neutrons. And so let's talk about this. So the only way to find the number of neutrons is by manipulating this equation right here. And it's pretty simple algebra. If I want to get neutrons by themselves, I just subtract protons. I subtract protons because it's addition, right? Cancel out. So I get atomic mass minus protons equals number of neutrons. The reason why we do this is because if you look on your periodic table, you will always be able to find the atomic mass, and you will always be able to find the number of protons. So let's do tellurium here. The atomic mass of tellurium, I go ahead and look on my periodic table. It says 127.6, right? I know my number of protons. We've already found it, 52. So I'll subtract that from 52. Will give me the number of neutrons. So I can so when I come up with my number of protons, neutrons, and electrons, they always have to be a whole number. I can't have a half of a proton. I can't have a half a neutron or a tenth or an eighth or anything like that. So this is why it's an average, and this is why we get a decimal, because it is an average. Okay. So I can go ahead and round this now, or I can round it at the very end. I always just choose to round it at the very end. So if I go ahead and I do 127.6 minus 52 minus 52. This will give me 75.6 equals number of neutrons. Again, you can't have a decimal for this. So I'll just go ahead and round this up. So that's 76 neutrons. Okay. Now what this is saying is for in the entire universe, when we're talking about tellurium, the tellurium atoms, for the most part, have 76 neutrons. Now, there are a little majority here that may have 75. There could be some that have 74. There could be some that have 77 neutrons or 78 neutrons, right? There's a small percentage of those guys out there. Like I said, think of it as a population. The average mass of tellurium is 127.6. The average number, most of the time, then they would have 76 neutrons. So if we jump over here, let's see how many neutrons on average iodine might have. So again, iodine's mass would be 126.9. All right, so I do 126.9, and again, this might as well be 127, right? You can go ahead and you can round that now. I just choose to round it at the end. I'm going to subtract this from my number of protons, 53. All right, and this will actually give me 73.9, right? But then I have to round this guy, so it'll be 74. So the reason why tellurium weighs more than iodine is because tellurium, on average, has 2 more neutrons than iodine does. Okay, and so that's all that there is to that. But that's just, in short, that's how you find the number of neutrons. And I know I talked a lot, but all you need to know is how to do this. Find the atomic mass, find the number of protons, subtract them from one another, and then make sure that your final answer is a whole number. It's that simple. I just talked a lot and told you why the atomic mass can be a decimal. It's because it's an average, okay? So anyways, next, you guys should have done energy levels, okay? So on that Google document, there were some energy levels. And so let's talk about energy levels. So if you look at your periodic table again, and you should be looking at something that looks something like this on your lab. Okay? And so if you look at this guy, that's upside down. If I have 8 protons in an atom, that means I also have 8 electrons. If I have 9 protons, I'll have 9 electrons, okay? And so when we start making these diagrams here for the electron configuration, there's a couple rules. So this is called electron configuration. Okay, and this is important. We have to get this. You're like, well, why do we need to know this? Where's this coming from? We're going to go over chemical bonds and how are chemical bonds formed. Well, they're formed from the electron sharing, or one being given up and the other one being taken and stuff like that. So first we have to go on the electron configuration and see what's up with these electrons. I think my computer's about to fall asleep. All right, so anyways, let's start with the smallest one. Let's see. So we have two rules here. First rule is that our first energy level can only hold up to 2 electrons. Okay? The first energy level. The second energy, and the first energy level is also the closest to the nucleus of the atom in proximity terms. Second, so there's a total of 7 energy levels. And how can you remember this? Why 7 energy levels? Well, the periodic table was made this way for a reason. So if I actually count the rows, okay, I go 1, 2, 3, 4, 5, 6, 7 rows. And then you guys are going to say, well, what's this little block down here? This is the lanthanide and actinide series. We will talk about those guys later. Anyways, you see this little black arrow? The lanthanide and actinide series actually goes up here. The lanthanium is 57, which is right here. Actinium is right here. And the reason why that we pull this down here is because this periodic table would then grow to be this long, and it'd be really hard to put all of that stuff on one page. So they take the lanthanide and actinide series and they just pull it down here. So actually, the lanthanide series is row 6. The actinide series is row 7. We just pull it out to make it easier for us to see it on a piece of paper. All right. So then, energy levels 2 through 7 can hold up to 8 electrons. Okay? And so if you guys notice, again, we're only going to really talk about the first 20 elements of the periodic table because those are the most common ones that are used in organics. So when we talk about the chemistry of the human body, like carbon, nitrogen, oxygen, all of those guys, those are the most common ones up to calcium, which is number 20. And then the rest of the guys we will kind of talk about, but they will not be the focal point of this chapter. Okay? But as we also look at this, so here's that scrunched down version of a periodic table. These are the representative elements of the periodic table. It's 1 through 20, 1 with hydrogen, and 20 being calcium right here. Okay, and if we count the columns, so columns run up and down. So we have column 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have 8 columns, and there can only be up to 8 electrons in each energy level. So again, we have 7 energy levels, 1, 2, 3, 4. So potassium would be right here on your full scale periodic table. Here's potassium, there's 4, 5, 6, 7. So 7 energy levels, and then there's 8 8 columns as we go across. Okay, so let's go ahead and look at this. If I want to look at hydrogen, the very first one on our periodic table, hydrogen. Hydrogen's our first element. If it has 1 proton, it must need 1 electron. All right? It has 1 energy level. It's in row 1. Right? If you look at your periodic table, you'll see that hydrogen right here is in row 1. Helium over here is also in row 1. So how many energy levels does helium have? It only has 1. So if I want to do the electron configuration of helium, helium has 2 electrons and 1 energy level. Now, let's go to our third element, which is lithium. Now we have hydrogen, helium in row 1, and then we start over with lithium, which is in row 2. If it's any element that's in row 2, we'll have 2 energy levels. All right, so I have lithium. So I go 1, 2. I can't put a third here because remember our rules, there can only be up to 2 electrons in the first energy level. So that third electron has to bounce out here, and we'll have to add that second energy level. Okay, there's lithium. Now, let's say if we want to do something like a little bigger. And you can pause it at any time if you need to catch up if I'm going too fast. Let's say if we want to do something like magnesium. Okay, so magnesium, if you look on your periodic table, has the atomic number of 12. Right? So this means it has 12 protons. But it also has, and we're talking about electrons right now, so this is what we're interested in, it has 12 electrons. So if I find it, if you find it on your periodic table, it has 1, 2, 3. I find sodium in the third energy level, and then magnesium's the second one over. So it's still in the third row, third row. So if it's in the third row, then it must have 3 energy levels. So let's go ahead and start filling the electron configuration out. So I need 8 electrons. Or sorry, I need 12 electrons. So my first energy level, I'm going to draw. How many can go into it? I can only put 2 electrons on my first one. 1, 2. Okay, now I need to fill up my second energy level. So this can only hold 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so right now I have 10 total. 2 in the first, 8 in the second, so I have 10, but I need 2 more. My second through seven energy levels can only hold up to 8 electrons, so those 2 electrons will spill out into the third energy level. Okay? And now if you wanted to talk about what's next, aluminum is 13. So if we wanted to do aluminum has 13 electrons. So then I would switch this out, right? Aluminum, and it would look just about the same, except instead of 2 on the very outer edge, there are 3. And you just keep adding the energy levels as you go down the rows, and you keep adding the electrons as you go across the columns. Okay? So, anyways, I hope those labs are doing good for you guys. Like I said, I'm trying something new, so let me know if they're not working, if you don't understand them. This stuff is kind of upper level. It is going to be one of our tougher tests that we have for this year. So please make sure you communicate. Please make sure you keep watching these videos. All right, bye.